Okay, so we're just going to show how to use some of these similar triangle theorems. The first one we'll talk about is angle-angle, which we can notate as AA. This is the angle-angle theorem. And you can write for this, if two angles of two different triangles are congruent, then the two triangles are similar. Now, if they're also the same lengths, congruent lengths, then it would actually be congruent triangles. We're assuming that they're not the same lengths. In fact, we would assume that they're proportional. We can see right here, these are not congruent lengths. AC is not congruent to RS, and QR is not congruent to AB, because QRS, triangle QRS, is actually smaller. So ABC, triangle QRS. So by the angle-angle theorem, since we have angle C is equal to 28 degrees and angle S is 28 degrees, and we have that angle R is 72 degrees and angle A is also 72 degrees, then we have two similar triangles. We know this by the angle sum theorem, because we know that every triangle, all interior angles, should sum up to 180. So if we were to kind of think about that, we're missing these angles Q and B, but we know that if we sum up angles R and S, or angles C and A, we end up with, what is that, 100 degrees? Between 72 and 28. So both of these angles are 100 degrees. And we know that when all three angles of a triangle are congruent, then they're similar triangles. So we say triangle ABC is similar to QRS. Now let's look at side angle side theorem. So the side angle side theorem essentially just says that if two corresponding sides of two different triangles are proportional, and I'm going to note with same ratio, and the angle between the two sides, the two proportional sides, is congruent to the other triangle's angle, then the triangles are similar. So there's probably a much more concise and simpler way to state this, and it's actually easier than it would appear to be. So we'll look at these two triangles. So we have to compare. Let's make this Q and R. Let's make this A and B. So we know that AB, let's do QR over AB. So we're comparing the length of QR, which is 15. And we know that AB is 3, which is equal to 5. And we know that angle R is equal to angle B. And of course, let's make this C and S. We also know that RS over BC is equal to 25 over 5, which is equal to 5. So we have these proportions, and we have our equal angles by the side angle side theorem. We know that triangle ABC is similar to triangle QRS. Cool. How about this one? Can you guess which one this is? It's an SSS theorem. That's side, side, side. So we have to make sure that these triangles are proportional given their sides. So sometimes it's kind of difficult to know which side corresponds to which, but usually start by looking at which lengths are the longest on each of them. And I'll use the larger triangle to go in the denominator, or the numerator. So I end up with a whole number instead of a number less than 1. So 35 over 7, those would be corresponding. Should be equal to, now our middle one, 6 and 30. So 30 over 6 is equal to 10 over 2. Is this true? Well, 35 divided by 7 is 5. 30 divided by 6 is 5. And 10 divided by 2 is 5. So by the side, side, side theorem, triangles, oh, now I gotta name them. I'll just say these two triangles are similar.